Hey guys, welcome back. Today we are going to discuss about reactive programming and Java 9 features. So first proceed with reactive programming. So reactive programming is nothing just a real-time data processing. So here you can see that reactive programming is an asynchronous programming paradigm concerned with data stream. So it is basically processing the data in real time. So in reactive programming, we define one thing like one data source and one data consumer and then we establish a connection between source and consumer, and then library take care of data flow from source to consumer. So earlier to Java 9, for reactive programming we were using Rx Java API. So Rx Java API, basically it have observable and subscriber. So here observable and then subscriber class. So let's see how we can use it. So in Rx Java we create a observable. So observable, like in this example we are printing values from 1 to 10, and here we have subscriber. So subscriber have three abstract method. So one is on next, on error, and on completed. So on next basically will print the values which is provided by the publisher. So publisher is basically a observable. Now here you can see like this is the source. The source have a method subscribe. The source dot subscribe, and then we are passing the consumer over here, and it will print those values. So here you can see like it will print 1 to 10 values. So this is the Rx Java API. So after that, in Java 9, we have the flow package, which contain the publisher, subscriber, and processor, which basically taking care of real-time data processing, means reactive streams. So here you can see reactive stream in Java 9. So reactive stream is asynchronous processing of data stream, so that we have already discussed. So when we discuss about data processing, then there is at least one data producer, one data consumer, and data flow from producer to consumer. So with the data pipeline in real time, and there is a processor to transform the data. So processor is basically transforming data from producer to consumer. So here in Java 9, reactive stream works on the same concept as we discussed earlier as Rx Java, and it have flow package. So like in Java 9 introduce flow package, and it contain publisher, subscriber, and processor. So here you can see publisher, subscriber, and processor. So let's see the example. So here we are creating example for using the publisher, subscriber, and processor using Java 9 API. So let's see how the publisher and okay. So let's see how the publisher and subscriber interface works. So publisher have an abstract method which is basically subscribe, and it's take a parameter subscriber, and then we have subscriber have four abstract method: on subscribe, on next, on error, and on complete. So here in the publisher, subscribe is basically when we are subscribing a subscriber using this method, simply we'll pass the subscriber as a parameter in the subscribe method. So the subscriber, so basically in subscriber, on subscribe method is will call when the initialization, like at the first time when the subscriber gets subscribed. On next method basically taking care of the data stream, like whenever the publisher will publish the data, so on next method will get those data and do the processing on that. And then on error method it will basically call when any kind of exception occur, and on complete will call at the last, like when the execution get happen at the last, the on complete method will call, and we can put some logic over here. So here this is the simple the main method, and we are passing this. So let's run this code. So we have written this code over here, simply the same code that we have seen earlier. So let's run this, and it is basically printing the value 1 to 10. So the subscriber gets subscribed on this line, and then it will printing the value. So value get printed on this on next method. So let's see further. So here I have written another method. So this method is basically similar to earlier one, but it have some conditions, like here we are initializing this publisher count 0, and when it is less than 10, less than 10, here we are simply passing the some random value, basically getting those value from system.nanotime, and then we have subscriber.onComplete, and onComplete will call once this execution happen, like all the data get printed in this loop, then the onComplete method will call. And then the main, like the same our class and the subscriber, and subscriber, here we're passing the subscriber, and subscriber, as we are discussed earlier, has this interface have four abstract method: on subscribe, on next, on error, on complete. And these methods are over here. So in the on next, we are simply putting a 1 second sleep, and then we are printing these random values. And here we are like incrementing this publisher counts plus plus, and then like the on error and on complete methods. So let's run this method again. So here you can see okay. So let's run this class. So when we run this, so this will basically printing the random values on a pause of 1 second. And here you can select it's passing for 1 second, and it will print 10 values. And after 10, the subscriber dot on complete will call, and the done is get printed in the last. So like you can see, the last done is get printed. Okay, so let's proceed further. So here we have discussed about the reactive programming in briefly. Let's proceed with the Java 9 features. So here we are Java 9 features. So in Java 9, earlier to Java 9, if we want to create like immutable collections, so we need to use the unmodifiable collection method of collections util class. But in Java 9, we have like a factory method, and using those method we can create the immutable collection directly. So in this code here you can see this is the code prior to Java 9. So here we have created a list of integer, and when we want to convert this list into immutable list, so we simply use this method and passing this list into as a parameter in unmodifiable collection method, and after that this list become a immutable list. So what is the internal implementation of unmodifiable collection? So this is basically create an internal class for the list, like internal list, and that in that list it basically override all the modifiable method and throwing an exception like unmodifiable exception from those method. So that's why whenever in this list, if we call the modifiable method like add, remove, the exception get thrown. So the next one is like the Java 9 implementation. So in Java 9 we have this factory method of like in list of set.of and map.of. So using this method we can directly create the table collection. Now there is no need of use this unmodifiable collection. And actually this list dot of, set dot of and map dot of is again internally converting this list into a immutable list. Basically it create another list, and that list all the modifiable method or the modifiable checkpoint are overridden, and the exception get thrown if those method are called. So this is about like the collection factory method of immutable class. Then the next is private and private static method in interface. Okay, so in our previous video we have discussed in Java 8 that in Java 8 default and default static method were introduced in interface. So in Java 9 the two new method private and private static method are introduced. But as these methods are private, so these can't be accessible outside the interface. Then what's the purpose of these private method? So these methods are basically the helper method for default and default static methods. Means the private method can be accessed inside the default method of interface, and similarly the private static method will be accessible from the default static method. So here I have written an example. Here you can see, so this is the default method, another is the default static method, and here we have the private method and private static method. So this method is called from the default static method, and similarly the private method get called from the default method. So this is the way like how the private and private static method are used in interface. So the next thing is improvement in try with resource block. So what is the improvement in try with resource? So actually try with resource was introduced in Java 9, and the resource which is auto closable can directly use in the try blocks. So here you can see the code of Java 7 like this. The try block, inside this we are creating a resource, and that resource will get closed, like it is actually implementing the auto closable interface, and it will auto close when this it will when the code come after this try block. So in the what is the constraint over here? So like this resource should be declared inside this try block. So this was the constraint in Java 7, and that is removed in Java 9. So in Java 9 there is no need to declare this resource like inside this try block. So we can declare this outside the try block. Like here we are creating the resource equal to new resource, and then we are passing this resource inside the try block. So then what is the use of like doing this? So the purpose, like as a development, there may be a possibility that when we are passing the resource as a parameter or some another method, so in that case this constraint will not work. So now here what we can do, like if a resource can be passed from the method, and that can be used inside the method in the try block. So there is no need to create that resource within the try block. So the next is a new method in stream API. So in stream API, new method were introduced. So basically in stream API, there are two new methods, take while and drop while are introduced. So what is the use of take while and drop while method? We can explain this through this example. Okay, so as name suggests, take while and drop while. So take while means accept until the condition meet, and drop while means drop until the condition meet. So here you can see we have created a list having these like these integer values, and on this list dot stream, and using this take while method and passing this predicate in the take while method, like a condition, if the values less than 4, then print all those values. So take while means accept all those values before this condition, like 1 2 3 4. So condition meet at this place, so print all those values before this condition. So it will simply print 1 2 3, and after that it will like drop all those values. And similarly in drop while method, it will check the condition. So like the condition less than 4, so it will drop the values, like it will check 1, oh 1 is less than 4, drop it, 2 less than 4, drop it, 3 less than 4, drop it. Then the condition 4, oh it is not less than 4, it is equal to 4, then the condition is not accepting this, then print those values. Now after this it will drop these values, and after this it will print all those values. So here you can see it will print all those values. The next feature. So the next feature is making a loop more functional, improved in stream. So in imperative style of code, when we are creating a for loop, so the loop can be written like this. So here we are initializing the count from 0, then we have the condition less than 10, and then incremental, and then we are printing this value. So the same code can be written in a functional style. So this is actually imperative style of code. And now in Java 9 it provide the iterate method in int stream. So basically int stream dot iterate, and here the initialization similar to this one, and then we have the here the predicate, like simply the condition, so condition less than 10, and then here the function like increment function similar to this, and then the for each loop and the printing the same values. So here like the same thing is written in this way. So this is basically an improvement in a the code to be written as a more functional style way. So the next thing is improvement in optional API. So earlier in like Java 9, there were a lot of issues with the optional API regarding the null values. So to avoid those values, in optional we have two new method, is present or else and or method. So using this method we can provide the default values. Here we have written a list of integer, and when we are using the like optional, so like int list dot stream, and then we have written a filter and then find first. So find first basically a return a optional, and in that optional we are, if that optional is null or empty, in that case we are calling this dot or method, like if find dot first is not present, then it will return a default value of 50. So that's the default value using this OR method, and here we are simply printing this. And the second method is if present or else. So basically stream, then the filtering and the find first. So like if this condition met and the value find, so simply we will get that value. But if the value is not present, so similarly as the method says, if present or else. If present, then return that values, or else simply return the optional value of value 50. So that's why like optional, here we get the default value for the optional. So the next thing is in completable future. So there is an improvement in completable future. Like in completable future, we can provide the timeout. So here you can see, to control the execution on completable future on time, we can abrupt the future on given time interval and returns a default value. So let's see in the code. So completable future. So here future completable future dot supply async, and there simply we are using system dot nano time, and then future dot then accept, and simply printing that value. Now in future dot complete on time, so this is the method. Here we are using complete on time, and it accept three values. One is actually default values, the second is the timeout, and then the third one is the what is the unit of this time. So here you can see this computable future doesn't execute on 2 seconds. So this is like the unit is second and 2 seconds. So if it doesn't execute on 2 seconds, it will return a default value of -1. So we are writing the same code in a different way, like in a functional style. So this can be written as completable future dot supply async, and then here it is the lambda function, and then or timeout, and the simple like similar to the above code, 1, and then say this is the units. Here we have written minutes, and then accept, simply printing the value. Okay, so the next thing in Java 9 is modular programming. So modular programming is the new feature, so which is basically used to avoid the heavy and bulky jar. So like in Java 9, we are using monolithic jars to develop the Java based application. In Java 9, modular programming were introduced. Modular programming provide a better way of developing an application. Earlier to Java 9, we simply create the jars, and jars become heavier and heavier. Like all the packages comes under that jar. But in Java 9, we can create the module, and simply define those module like this. So simply like in JDK itself, it has divided into set of modules to take it more lightweight, like rt.jar, so which is basically the JDK, and that is already divided into several modules. So it's also allow us to develop modular application. To enable modular programming, create module-info.java on parallel to your base folder, and in below code snippet requires the use of import module and export to use the export package. So requires is used like as this requires is used to import the modules. So here in our module, we simply specify all those modules that are required for our modules using this keyword requires, and export is used to export the package. Like within our module, the package that we want to export, we simply declare those packages using the export keywords. So note, by default all modules uses requires base dot like java dot base, so that needs not to be declared explicitly. So all the modules by default using requires for java dot base. So the next thing is reactive programming that we have already discussed, the flow package, and inside the publisher, subscriber and processor are interface are introduced, and we can use these interface and provide the implementation for reactive programming. So the next thing is Jessel, which is basically a REPL, read, evaluate and print loop. So actually this is more interesting feature. So this is basically only the purpose of Jessel is for the learning and for the rapid development, and it is used for the research purpose. So in Jessel, we need not to create the complete Java class and method. We simply write the one line of code, and that code will get executed directly in the Jessel. Like here you can see, like I have a snippet. So for the Jessel, just go to the bin directory of Java, and inside that the Jessel.exe will be there. You simply run that file, and then the Jessel will be in the like command prompt, and inside that you can put your Java like function simply system.out.println, and it will simply print the method like this, and int a equal to 10, int b equal to 10, and similarly c equal to a plus b. So like this, all the method all the function can be printed in Jessel. Let's see some example of Jessel. So here I have opened the Jessel prompt. So in the Jessel we can simply write the one line of code, and that code will get executed directly, and there is no need of any class and method. So let's write a code like system.out.println, and then here I'm writing mk study journal and printing this. So this is simply printing the MK study journal. So like there is no need of writing the complete code. Let's see the int a equal to 10. So the beauty of Jessel is like there is no need to put the decorative key things like the semicolon and any other thing that are mandatory in the Java class file, as that will give a compiler error. But in Jessel there is no need to write all those things. We simply write our code like simply logic. So int a equal to 10. So here the value 10 is assigned to a, then int b equal to 20. So here the value 20 is assigned to b. Now in the third line, if I am writing int c equal to a plus b, so here the Jessel is smart enough, it know that the value of a and b is 10 and 20 respectively. So it will simply provide the addition and provide that and assign that value to c. Here you can see the 30 is assigned to here. So here you can use the list method basically. So this will provide all the method that are written so far. So here list you can see the first line we have written the system.out.println, then int a equal to 10, then b and c. So these are the function that we have written so far. Even you can use the edit method to open the notepad and update that notepad here, like the same thing over here. And here even you can update the values, and that values get reflected over here. So you can simply update those values and then simply close that, and here you can use that list again print those values. So and also you can use the help method. So help will provide all the relative functions and method that can directly use. So this is all about the Jessel. So here you can do more and more R&D and learn Java. So that's it in Jessel. So let's see what's remaining in Java 9. So these are the actually the important features of Java 9. So that's it for Java 9 and the reactive programming. So thank you.